Okay. Okay. This session is really about reviewing for your exam on Friday. The solutions to the review questions that were posted online, the solutions are now available. So you also have that as a backup as well. Does anyone who joined, I can see I have Josh and John here in the room, do either of you have any specific questions or a place you'd like to start? Okay. Well, then I guess we will just start running through some of these problems and see how far we get. Okay? So I'll start with the exam review because I think that was broader than the taping handout. So the first question of the exam review, oh, I gotta hit the pen. Oh, come on. There we go. Okay, welcome Annie. If you have any specific questions or any problems you'd like me for sure to go over, please speak up. This session is really, more for you guys to make sure that you get your questions answered. So Michelle, welcome. Same for you. If there is any question that you have specifically or anything specifically you'd like me to go over, please go ahead and say so. Otherwise, I'll just start running through some of these problems and see how many of them we can get through. The first question was the number of paces counted each time was 35, 36.5, 36, 35.5, 35, and 36. Now the surveyor Now the surveyor paces a triangular parcel of land. The first leg is measured as 120 paces. The surveyor now turns 90 degrees left and paces 90 paces along this side of the triangular lot. What is the standard pace length in feet per pace of the surveyor? This is directly from our first lab. So you would take each of the pacing measurements, 35, 36.5, 36, 35.5, 35, and 36. Sum them up, you get 214. There were 6 attempts, and I believe the question told you that they paced 100 feet. So 214 divided by 6 is equal to an average of 35.7 paces. Per 100 feet. Okay, and the question is asking you for feet per pace. So 100 feet divided by 35.7 paces equals 2.8 feet per pace. Okay, that's part A of the question. Oh, I think someone else joined us. Is anyone on the telephone and not in the session?
Yes. Me.
Oh, hey.
It's Kathy. Hi. I'm trying to get in, but I've been trying for several minutes here. But let's see. I went to student log. Let's see. Student login, right? I push on student login.
Yes, you need to go to the cccconfer.org website.
Yeah, I'm there. I'm there.
Okay, and then underneath the Teach and Confer,
right?
You do student login.
Right.
Okay.
I did that.
And then you find our session and click Go.
Okay, so it should be okay. So I don't see it right now. Should it be on the top? I see a 6 p.m. to 9 p.m. One, but is it stacked further?
Hold on.
Oh, there it is.
Okay, let me get to where you are. Oh, you found it? Okay.
I push Go.
And then click Go. Yep. And then now you should be able to put your name in, your email, the passcode.
Okay, there it is. Hold on a second. I got to put this on now. Okay, I think I got it now. I've done this a number of times before, but not actually live. I've just gone to look at the archive. So.
It's okay. Is it loading?
It's going. Yeah, it's going. There it is. Here I come.
Oh, perfect. Yep, there you are. Okay, now Kathy, it's up to you whether or not you want to stay on the phone, but you might end up with an echo. Okay, so Kathy's in. I'm assuming she can hear me, and we will continue to move forward. So this 2.8 feet per pace is part A of question 1. The next part of the question B says, what is the length in feet of the third side of the parcel? We know that the first leg of the triangular parcel was 120 paces. The second leg was 90 paces. So what we're going to do here is we're going to convert that. So 120 paces times 2.8 feet per pace gives us 336 feet. And then 90 times the 2.8 is 252 feet. So to calculate the third side of our triangular parcel, we have good old Pythagorean theorem, where A and B are the two sides of our triangle, right here and right here. Now I've seen people try to do this with paces and then convert to feet at the end, but that's much more complicated because you have squared terms here. So you can't convert using 2.8. You have to convert using the squared, and it's just a big mess. It's much easier to convert your paces to feet first and then calculate from there to make sure you're calculating in feet. So C is equal to the square root of a squared plus b squared, which in this case is 252 squared plus 336 squared, which if you do out the math gives you the square root of 176,400, which gives you 420 feet. Okay? So that is B. Part C says, what is the area of the triangular parcel in acres? So the area of our triangle is equal to 1/2 times the base times the height of the triangle is equal to 0.5 times 336 times 252, 2, and that's going to equal 42,336 square feet. In order to convert that, 1 acre is equal to 43,560 square feet times our 42,336. There we go. Square feet. So our feet cancel. We're left with acres, and we get 0.97 acres. Okay. Any questions on that first problem? Okay, and as I said, if anybody wants any particular problem or type of problem solved, please speak up. Otherwise, I'll just keep sort of plugging through them, but we probably won't get through them all. We will get to look at our formula notes or no? No. I attached, where did I attach it? With the sample problems, I believe, I attached the formula sheet that you will be given during the exam. So you will be getting the formulas, but, that's a good question, John. So yes, you'll get a formula sheet attached to your exam, and I attached the exact same formula sheet in Blackboard so that you would know what formulas you're getting. But it doesn't come with any of the descriptions of the coefficients or what they represent or anything like that. It's just the actual formulas. No, you don't need to remember the actual conversions. You'll be given any of the conversions that you need in the exam. Okay. So the next one is a distance of 287.54 feet was measured along a 2% slope, starting at station 0 plus 0, 0. The elevation at that station is 1,237.35 feet. What is the horizontal distance? Okay, well we remember, so this is number 2, we remember that slope is equal to rise over run. Okay, it sounded like someone else perhaps joined us on the telephone.
Well, it's Kathy, and I can't seem to get the chat thing to work for my. Is there something I'm supposed to push that I'm not aware of?
Something that you're supposed to push? No, you would just click in the box at the bottom. That underneath all the chat words there's a little white rectangular box. You would just click your cursor in that box and then start typing.
Oh, I get it. Thank you.
Okie dokie. No, Josh, you do not get to use any notes during the exam. It is a closed book exam, but you will be given the formula sheet. And like I said, the formula sheet that you will be given has already been posted in Blackboard, so you know what formulas you'll be getting. And if, I always recommend to students to do the review questions with that formula sheet, because that'll give you a sense of whether or not you have what you need or you know what you need to know. Okay, so let's see here. So the picture we're looking at based on the question okay, there we go. Our 2% slope and the distance of our slope from here to there is 287.54 feet. Okay? So the first thing that we need to do is determine this angle. If the slope is 2%, then every 100 feet horizontally, the change in elevation will be 2 feet. Does everybody agree with that? What is she doing over there? Okay, so we can say that the tangent of theta is equal to 2 over 100, right? Because the tangent of the slope, right, tangent of this is equal to rise over here. Come on, little pen. Over run here, right, which is equal to our slope. Our slope is equal to 2%, which is equal to 2 over 100. Okay? So the tangent of this angle is equal to 2 over 100. Therefore, theta, the angle, is equal to the tangent inverse of 0.02, which is equal to 1.15 degrees. If we were actually reporting this as an angular measurement, we would convert this to degrees, minutes, and seconds. But for right now, I'm just going to use this to calculate for calculations. So I'm not going to convert it because your calculator needs it in a decimal format to calculate. So there's no reason to convert it and then convert it back. So we need our horizontal distance. That's this down here, the run, right, which is h, our horizontal distance. H is equal to 287.54 times the cosine of 1.15 degrees. So H is equal to 287.48 feet. And I think that covers A. I think that and this were part of A. B, whoops, part B is what is the elevation of the road. Our vertical distance there, our rise, is equal to the 287.54 times the sine of 1.15 degrees. Which is equal to 5.77 feet. So the elevation here is equal to the elevation here plus V. So we get 37.35 plus 5.77, which is equal to 1,243.12 feet. That's that. And then question C says, what is the stationing at that elevation? So what's the station here? Well, that's simply the distance h. So it's 2 plus 87.48. Okay, we good? Okay, moving on. Taping problems. Okay. A 100-foot steel tape of cross-sectional area 0.0015 square inches, weight 2.5 pounds, and standardized at 68 degrees Fahrenheit is 100.008 feet between end marks when supported throughout under a 10-pound pull. So that's giving us our standard conditions for our tape. The question is, what is the true horizontal length of a recorded distance AB if AB was measured to be 235.80 feet? At the time of measurement, the average temperature was 89 degrees Fahrenheit. The tape was supported at the ends only, and there was 22 pounds of tension on the tape. Okay, first question we have to ask, is this a fixed point or a layout problem? Yes, fixed. Excellent, Kathy. Because it says the true horizontal length of a recorded distance AB. So you have 2 points that you've measured between. That means it's a fixed point problem. Okay, so let's start with our tape length. The standardized tape length is actually 100.008. So we know that we have a long tape, but we're using it as if it is a 100-foot tape, right? 100.00 feet. So our correction for length is equal to our actual tape length minus our nominal length divided by our nominal length times the distance that we measured. okay, which gives us okay. We also know that we need to correct for temperature. At the time of measurement, our temperature was 89 degrees Fahrenheit. Our standardized temperature is 68 degrees Fahrenheit. So, oh goodness, sometimes this doesn't work so well. There we go. Our correction for temperature is equal to our coefficient times the difference between our standardized and measurement temperature times the length that we measured. Our coefficient is a given, and it is 1, 2, 3, 4, 5. That's our temperature coefficient for the units that we're using, English units. There's the difference in our temperature, and we're going to multiply that times 235.80, the length that we measured. When you calculate that out, you get 0.032 feet. That's the amount of correction that needs to be applied for temperature. We also know in this problem that we need to correct for pull. It was standardized under a 10-pound pull. At the time of measurement, there were 22 pounds of tension or pull on the tape. So we have 22 minus 10. That's the difference between the pull at the time of measurement and standardized pull. And then you have L, the distance that was measured, divided by A, the cross-sectional area of our tape, which was given, times E, which is the modulus of elasticity for steel, which is a constant, and for our English units, it is 29 million. Multiply this through, and you get 0.065 feet. That's the amount of the correction that needs to be applied for pull. Okay, the problem also stated that at the time of measurement, the tape was supported at the ends only, which means we must also correct for sag. Okay. Who remembers what the little W represents? This one right here. Because this is one of the most frequent mistakes that I see when people calculate sag. Yes, the weight of the tape per unit of length. So, based on the question, the problem, the tape weighs 2.5 pounds. What is little w? Yes, 0.025. Great job. So, yes, good job, guys. 0.025. That is a huge mistake that everybody makes, or many people tend to make when doing these problems. 0.025. 0.025 squared. Now, here's the other big mistake everybody makes. Notice that this term here is L sub s. What does that mean? Why is that an L sub s and not just an L? Length of sag, right. It's the amount of tape that is actually sagging at the time of measurement. So if we measured 235.80 feet, how much of that length is sagging at any given time? Well, yes, all of it, of course, but does that mean we put 235.80 here? Okay. If I have a distance from A to B, and this total distance is 235.80 feet. But the tape I'm using is 100 feet long, correct? So we're going to assume that there's 100 feet, there's 100 feet, and there's 35 feet. So when I stretch my tape, I have sag here, and that's the same amount of sag that I should have here, because this is 100 feet, and this is 100 feet, and we're assuming the same conditions. In other words, we're assuming that the pull and the temperature and everything else is exactly the same when we take this measurement. Then we're here, and we're at 35.80 feet. Is this sag here going to be the same as the sag here or here at 100? No, right. It's going to be less. So this L sub s here is the length of unsupported tape, not the length here, like here and here, that was measured. We're not talking about the length measured. We're talking about the length of unsupported tape. So we have 100 feet unsupported, and we have it twice. So whatever correction you have here, you have it again here. Does that make sense? Okay, so we have 2 times this correction, and then P1 squared for this problem is 22 pounds squared. Okay, so when you do these sag calculations, those are the 2 mistakes that are most frequent, is not calculating the small w correctly and then using the entire length instead of the individual length in order to calculate this. So if you calculate this out, you get so basically you have 1/10 of a foot in error. That's quite a bit. 1/10 of a foot in error just from the 200 feet of measurement. The P is pounds of tension. Yes. Yes, the P is the amount of pull or the amount of tension that's on the tape during the measurement. Okay, but we're not quite finished yet. We need to do this whole calculation for sag again for the remaining 35.80 feet. Okay, but now look how insignificant this is. 2/1000 of a foot. That's nothing. Absolutely nothing. It's essentially negligible. But the sag from the 100-foot pieces is actually significant. It's 1/10 of a foot. Okay, so we're almost finished with this problem. Okay, so what have we done here? We've calculated the value of the correction for each type of correction. So we need to correct our measured distance by this much here for length, by, this might make it a little bit easier. Come on, come on. All right, well, maybe I'll do this. It'll just make it different. There we go. Okay, so we need to correct by this much for length. We need to correct by this much for temperature. Here's our value of correction for pull. And here is our corrections for sag. Okay, now we actually need to apply those corrections. Here's where that lovely little chart that's at the bottom of the handout comes into play. So it says for construction layout. Now this chart is not on your exam or on your formula sheet. Because this isn't really a formula, this is just one of those little helpful little things, like helpful little shortcuts. Okay, so we have a fixed point problem. For a fixed point problem, you subtract the correction if it's short. You add the correction if it's a long tape. So we started out with our length of 235.80 feet. Our correction for length is 0.019. Do we add or subtract this correction? For the case of length, is it a long tape or a short tape? Correct, you add it because it's a long tape. So now we look at our next correction temperature, 0.032. Do we add or subtract the correction for temperature? Looks like we add. The temperature is warmer, gives us a long tape. So if we have a long tape and it's a fixed point problem, we add it. Now we look at our next correction. Pull, 0.065. Oops. There we go. Do we add or subtract for pull? Once again, we add because it's a long tape, meaning that 22 pounds of pull over a standard pull of 10 makes this correction a long tape correction. Okay, now we need to correct for sag. Sag is always a short tape, so we subtract our correction for sag. And you can also subtract this tiny little bit here. It's pretty insignificant. Now, when you apply all of this to this, so basically when you add and subtract all these numbers, you come up with 235.806 feet. At which point we only need or only have two significant digits. So it didn't end up making such a big difference after all, right? But that's the way these problems are done. You need to take them piece by piece and apply them piece by piece. Okay, we only have a few minutes left, although if anyone wants to stay later, I'll be happy to do more problems. So which problem or problems would you like me to go to next? The next problem on the review is another taping correction problem. It is for a construction layout type problem. Or we have the leveling loop problem, number 5, which is the last one. Oh, somebody would like to see number 4. Works for me. Okay. Got it. Oops. So number 4. A 100-foot steel tape of cross-sectional area 0.0020, let me say that again, 0.0020 inches squared, weight 1.5 pounds, and standardized at 68 degrees Fahrenheit, is 99.985 feet between end marks when supported throughout under a 10-pound pull. That's our standard conditions. What is the true horizontal length of CD that must be laid out to achieve the required horizontal distance of 123.61 feet? So you can see how that is phrased very differently than your fixed point problem. At the time of measurement, the average temperature was 87 degrees Fahrenheit. The tape was supported throughout, and there were 30 pounds of tension on the tape. Okay. So the first thing we need to do is figure out what we need to correct for. So we know we need to correct for length because it tells us that under standard conditions our tape is 99.985 feet. But we're using it as a 100-foot tape. So we use the actual length minus the nominal length divided by the nominal length. Josh, you are correct. We will need to correct for length, temperature, and pull. And we're going to multiply this times our layout distance, L, which gives us negative 0.019 feet. We need to correct for temperature. Again, that is our constant, the difference between the temperature at the time of measurement and the standardized temperature, times the length that we need to lay out. Okay. Correct for pull or tension. So the difference between pull at measurement and standard pull multiplied by the length we need to lay out divided by cross-sectional area of the tape times our constant. If you punched all that into the calculator correctly. That is the other error actually that I see on the exams. Be really careful when you punch these formulas into your calculator. If you don't hit them in the right order or store a certain memory or however your calculator functions, you end up with multiplying or dividing out of order and then getting crazy answers. So at the beginning I got for length. Okay, Kathy, is this the same formula? Is this the same numbers in the same way? Yep, okay. I'm going to guess that you probably just figured out where you went off. Okay, so we determined the correction for length, we determined the correction for temperature, and the correction for pull. Those are the only three corrections for this problem that need to be applied. So we have our original length that must be laid out of 123.61 feet. Now, so I don't have to draw it again. This time, I'll use green. This time we have a construction layout problem. So for length, and looking only at length of the tape, is it a short tape or a long tape? Short. Excellent. So, oops. According to our table, if we have a short tape and it's a construction layout, we add the correction. So we add .019. Okay, even though there's a negative here, we're going to assume this to be an absolute value and ignore it. So we're adding 0.019. Now, for temperature, is it a long tape or a short tape? Long? Yes. Construction layout, long tape, you subtract the error. So we're going to subtract 0.015. Now for pull or tension, is it a long tape or a short tape? Long. So once again, Kathy, why do you say short? Our pull at the time of measurement was 30 pounds, and our standardized pull is 10 pounds. So we are pulling more than the amount of pull that was placed on the tape when it was constructed. That makes it a long tape because you're stretching it. Okay, so minus 0.043. Those are the only corrections that we have to apply. So when you add all of this up, you get that L equals 123.571, which would be 123.57 feet. So what this is telling you is that, yes, sag would be added. because SAG is always a short tape. If we have a construction layout problem with a short tape, we add the correction. So much as we did here with length, this was a short tape we added. So if we had SAG, we would have added the correction for SAG. So what this means is that using the tape that we're using, we would need to lay out a distance of 123.57 feet with that tape under these conditions to get the true value or the true distance that we're trying to lay out. Okay? So I gave you also a taping handout and a set of taping problems, a whole page of taping problems, because many students really struggle with these taping problems and applying the corrections correctly. So you have plenty of practice problems to work with, both for fixed point and layout situations. Yes, there's those on here. And the solutions to those worked out just like we were working them out here. Those solutions have also been posted in Blackboard. They are on the Homework Solutions tab. That's where you'll find all of the solutions to the problems that were posted. How many questions are on the exam? Hang on one second. I think I posted that information in Blackboard, and it's too late in the evening for me to tell you off the top of my head. So I'm logging in to Blackboard as we speak. Okay. Also, your lab information is up and available as well. That has also been posted in here. Here we go. Your exam has 11 multiple choice questions, 1 short answer question, and 6 problems. All right, I can see there's some other questions here. Hang on, make sure I got them all. Okay. Extra taping problems are in the homework. The extra taping problems and the exam review problems are both found. Oops. I'm checking in Blackboard as we speak to make sure I don't say it incorrectly. They are both found under week 6, October 1 through 7. The first item listed is exam number 1 review, and there are some sample problems there and your formula sheet. And then right underneath it are taping problems, and there's a page of taping problems and the taping handout. And then the solutions to all of those problems can be found on your Homework Solutions tab. Yes, they're all there and available. So, and they're all worked out just like I did here, although they're typed, so they're a little bit neater. Okay. Are there any other questions? I think everything that you need is in Blackboard. If you look and you can't find something or something seems to be missing, send me a quick email and let me know, and I'll either help you find it, or every once in a while I forget to push a button and then it doesn't get posted. So, but I think it's all there. How long will you have for the test? The first half of the lab, so in the morning when we get there on Friday, we will do our distance measurement and angle measurement lab. And then we will break for lunch, and then after lunch you will have from then till 3:30 to complete your exam. You will have more than ample time to complete the exam. You know, I'm guessing 2.5 hours, but you shouldn't need that much time. But I don't do speed test, so I like to give students plenty of time. The other topics that you had listed on the exam review, are there any other topics we need to study or just the ones listed? That's an excellent question. I think it was just the ones listed. Let me go back and look really quick. Yeah, pretty much it's just the ones listed. Those are the, I mean, you know, definition of leveling terms and acronyms, that actually covers quite a lot of different terms. There are definitions. Yes, there are a few definitions, and those are the types of questions that you will see in the, what did I say it was, 10, 11 multiple choice questions. Then, like I said, there's one very short answer question, and then the rest of them are problems to solve. Okay. Any other questions? Yay. Awesome. Okay, well, thank you all for joining me this evening. I am going to go ahead and stop the recording. And you all have a lovely evening, what's left of it. I will see you on Friday. If anything comes up between now and then and you're going over these problems and you have another question, by all means, please, please, please send me an email, give me a call. I do have a couple meetings on my calendar tomorrow, but I will be in my office most of the day. So, so feel free. Thanks so much, you guys. Have a great evening.